I just completed this very tedious problem, which in my opinion is not a good problem. It's just a lot of fumbling around of weird edge cases and kind of feature engineering things. So let's pick a new medium level algorithms problem and hope we get a better one. Okay, apply discount every n orders. There's a supermarket that is frequented by many customers. The products sold at the supermarket are represented as two parallel integer arrays, products and prices, where the ith product has an ID of product sub I and a price of prices sub I. Okay. When a customer is paying, their bill is represented as two parallel integer arrays, product and amount, where the jth product that they purchase has an ID of product sub j and amount sub j is how much of the product they bought. Okay. Their subtotal is calculated as the sum of each amount sub j times price of the jth product. Okay. Seems pretty straightforward. So we stock some, we'll call it our product catalog. We got products and prices where each index into these same size, same dimension arrays. That's going to give you product ID and price. And here we get product ID and amount. So quantity, and then we have to kind of dereference that from product ID to find the price. The supermarket decided to have a sale. So every nth customer paying for their groceries will be given a percentile discount. The discount amount is given by, okay, it's provided to us as an argument. Where they will be given discount percentage off their subtotal. More formally, if their subtotal is bill, then they would actually pay bill times 100 minus discount, blah, blah, blah. Okay. Implement the cashier class. Initializes the object with n, the discount, and the products and their prices. Okay. Double get bill returns the final total. Answers within. Okay, so this is just for float precision. Okay. Off the bat, this problem is much better than the previous one. This is more kind of real world. Before we look at the example here, because these inputs are always confusing, like let's look at the constraints. So what is n? Every nth customer. Every nth customer? Oh, I see. So it's kind of random, like every fifth customer, for example. What was n here? 3? So the third customer should get the discount. Okay, cool. So we need a tracker for so we want a few things. Tracker for which customer, how do I want to say this? Which index the customer is in line for lack of a better, what's their ticket number basically. We'll want a storage for, we'll want product ID to price, and we'll need to store for the discount. So this is already set up as a class for us with a boilerplate. So the discount, basically it's valid, 0 to 100. Number of products. Okay, this is important. The length of prices is the length of products. And the length of the amount should be, okay, the elements and products are unique. That's important. All right, these are all sensible. These are all sensible. Okay, cool. So essentially, we're going to want to use a hash map so that we get constant time reads to access the price when we're actually ringing these things up. So I think we can do, we'll set up a few variables. So self.discount equals discount. We'll just pull this in. We'll do self.catalog equals, how do we want to build this? What's the kind of best way? We'll do I guess we'll do it up here. Why not? Actually, we'll just come up here and yank it. Okay, so we'll return a dictionary. So we can assert len. So this is an assumption from the problem, but we can just make it again here. So for I in range length products, and forgot we need a tracker. So customer index will start at 0. We'll start at 1. So right now we're going to build a catalog. So it's going to be return. So for I in range, length products. Fairly straightforward. This is just iterating through the products and prices and filling our catalog dictionary. Okay, so for get bill, there's kind of a few steps we need to do. The first is the same for any customer. So first I didn't mean to submit that, sorry. I did not mean to submit that. Second thing, check if discount is to be applied to this purchase. If so, apply return total. We don't have to take tax into account here, do we? I don't think so. Okay. So to calculate the total, we basically do a very similar iteration as we do here, but we're going to read from the catalog. So what we'll do is, again, we'll make another assertion. And then for I in range length, well, I guess we could do this. We'll call it product ID. Yeah, I like that better. More Pythonic, huh? Yeah, we'll set it like that. Okay. That's just a little bit of cleaner Python, I think. The other way would have worked too, though. Okay, let's see. If customer index, oopsies. I think we'll start this at 0, and we'll increment it here. Self.customer index plus equals 1. If customer index mod self dot n, we can just yoink this. Oopsies. Return. I guess let's call it Bill. We'll do that. Okay, so at that point, we return the total, and the next customer that we call get bill, we will. Okay. Let's just sit here before we submit this and let's go through everything we're doing. So we initialize this, we're given the n, which is every n order we apply a discount, just part of the promotion they're running, I guess. We take the discount and we're just storing these here. Take the customer index, and then we're actually building a catalog based on the products and prices. And this build catalog is just returning us a dictionary with key of product ID to price. Okay, so that all makes sense. Then when we call get bill, we've got a bunch of products and amounts. So likewise, we iterate over all the products. And to our bill, we add, I guess we can just initialize that to be a float. In Python, it doesn't matter, but in a proper language, wink, wink, it would. So let's see here. If customer index mod, so basically if this customer's our lucky discount winner, we'll cut their bill by the discount, and we basically just took this, which having worked on product catalog data professionally, I can tell you that this is how I've seen discounts done as integers, just because floats are not ideal when you're dealing with money. Anyways, that's an aside. Let's run this here. And we probably made a few small errors, but product, yeah, I did mean products. Oh wait, I didn't mean it. I think this should be called products though. Yeah, I think that's the problem, that didn't have that set up very well. Gotta love class. Object-oriented programming. Cool, okay, let's submit it. Let's see. Then we'll talk runtimes and space-time complexity. Okay, cool. So yeah, pretty straightforward problem, but I like this problem. I think this is a good interview problem for maybe a junior role, internship, maybe up to mid-level if you have some other problems added there. Because it's well laid out. The instructions are very clear. There's not much ambiguity. It's pretty easy to follow. Everything's kind of what you'd expect. It's not some terribly difficult programming that needs to happen, but you get an eye for setting up some, initialization and trackers and stuff. So not bad. I would personally say this is probably an easy and not a medium, but it's a good problem. So let's go over the analysis here. So when we initialize, we're basically just copying things over, but when we call build catalog, this is going to be an O of n operation. So with respect to the number of products, because we're iterating over the products, which is again the same length list as prices, and we're inserting elements into a hash map, which is constant time. So this is bounded by O of n, and it's also going to take up O of n extra space. For get bill, it's the same thing. This is going to be linear with respect to the number of products, because the hash map read, and the whole reason we added a hash map is so that these reads are constant time rather than linear time. If we left this as a list and we had to traverse the input list. So this hash map really speeds this up and gives us better time complexity in exchange for a little bit more space usage in the form of O of n more space. So that was 1357 apply discount every n orders.